Good morning, and thank you for joining me for another sprinkler talk. So this is episode 23, and we're looking at the sprinkler testing and maintenance routine. Again, I kind of looked at this and I decided to split it, kind of splitting it into two parts, kind of splitting it into three parts, because actually there's a 25-year sprinkler inspection, which I sort of think deserves its own sort of spot, really, because it is very different to everything else to do with the sprinkler testing and maintenance. So that's got its own presentation. So that's kind of part three, if you like, or 25-year inspection. And then the kind of the more regular sprinkler testing and maintenance routine, I'll split into two parts. So today is the first part, and we're going to look at what is required on a weekly basis and on a monthly basis. And then after that, we're going to do some of the other bits going forward, more of the quarterly, the yearly, and things happen every 3 years, every 5 years, which is mostly down to the tanks for the 3, 5, and 10 years. So let's get into it. So to start with, a good place to start is again talking about code standards. So got a bit more of an introduction of what exactly am I talking about. I'm talking about UK sprinkler codes for commercial industrial applications during this presentation. So the residential testing and maintenance routine are actually covered in Sprinkler Talk episode 16. So if you want to know about residential testing and maintenance, you can go back and have a look at episode 16, which talked about that. And that was entitled Residential Sprinklers Part 2. So yeah, I'll be looking at the LPCB rules for automatic sprinkler installations, incorporating BSEN 12845/2015. That's kind of its full title. I think in our industry and lots of other kind of construction industries would call it different things and might just call it the codes or the sprinkler codes or the LPCB rules. So, generally speaking, that they're all kind of interchangeable, but it is important to kind of understand exactly what this is that we're actually saying. So, there are other UK and international sprinkler codes. This is the one that is most commonly used in the UK. So the rules are you can say called the LPCB rules. So the LPCB is the Loss Prevention Certification Board. It incorporates the British and European Standard 12845. So I think I've shown you my rule book in the past on Sprinkler Talk. So I've got a big red folder, and the first half of that is the British Standard 12845, and so the most recent version of that is 2015. Then the kind of the other half of my rule book is based on technical bulletins, which are published by the FPA, the Fire Protection Association, and together they make the LPCB rules. As I say, testing and maintenance schedules for other code standards may vary. So as I say, there are other national and international standards which are going to do things slightly differently. Generally speaking, the actual what you do is very, very similar across the board. How often you do it is the thing that kind of varies from place to place. And in fact, it varies from place to place, even in the UK. Because you can see here, I've got the weekly routine, and I've got the page kind of split into two, showing the kind of purple on one side and white on the other. So on the left-hand side, on the purple bit, I have what is written in the British Standard. So section 20, section 20.3 covers the routine, and this is the weekly routine taken from the British Standard. As I mentioned, we've also got technical bulletins, and on the right-hand side we have the technical bulletin TB203, which is the technical bulletin version of the testing and maintenance routine. And these actually vary slightly. As I say, in terms of what you do, very, very similar. The only difference is kind of how often you do some of these things. Some of the things you have to do are kind of jump from one category to another. So we'll kind of pick up a little bit on that as we go through. But for the purpose of this presentation, let's focus on the left-hand side, which is the purple side. But so just keep your eye on what kind of spot the difference, if you like. So you can see here, all of these are pretty much the same, other than we have an extra one on technical bulletins, check remote monitoring station. So you have a remote monitoring station, then you would check to make sure that those signals are being received, checking that the kind of everything's online and it's working, and you would do that on a weekly basis. So what else would you do as part of the weekly routine? Obviously, I've kind of summarised these points. So if you want to read the full text about what you have to do, then you can look that up in section 20.3.2 of 12.5. But I've just kind of summarised the points down to just like one sentence for each thing. Check water and air pressure gauges. So yeah, it's basically just walking past some of the main equipment. So your B gauge, your C gauge, and your A gauge, essentially. What's the pressure above the alarm valve? We've gone within the riser. What's the pressure below the alarm valve? And what is the pressure at the fire pump? You know, is that pump, is the water primed and ready to go? So that would be a case of just walking past the pressure gauges and having a look. And most of the time, you're just checking that the gauge is reading the same value that it was last week. So if it's a water gauge, maybe it's 4 bar, 5 bar, something like that. You would just go over to the gauge, you have a look, and just make sure that it's still registering the same figure. If it's an air pressure gauge, so maybe you've got a dry installation control valve, and that will be charged with pressurized air. So again, you would check all of the key gauges to make sure that they're all running appropriately. Number 2, check water levels. So what we're talking about there is really the water storage tank. So you're making sure that there is water in the tank. You could do that just by checking the monitoring panel. So again, there should be a high and low water alarm. So if they haven't sounded, chances are that we're good. The water tank will also have what's called a telltale. Oh no, it's not called a telltale. That's for leaks, I think. You have a clear sort of pipe that comes out of the side of the tank and rising up. So that a sight glass, I think it might be called. So the water in that pipe will be the same level as in the tank itself, and you could have like a coloured ping pong ball just kind of sitting in that glass tube, and that will obviously tell you the level. So you can have a quick look at that and make sure that there's water in the tank. Number 3, check correct position of all main stop valves. So I suppose a question is, what is a main stop valve? For me, that's anything up to and including the installation control valve. So zone valves would not be a main stop valve, but stop valves at the connection to the tank, connection to the pump, underside of the alarm valve, above the alarm valve, all of those are main stop valves. But if one of those is closed, you've lost the water to the whole installation. So how do you check that they're in the correct position? Again, two ways really. One, you may well have monitored valves, so you should be checking the panel to make sure that there's no fault alarms at the panel. And also you could just walk past them and you could just have a quick look. Each valve has got an indicator paddle on the top, and if that paddle should be perpendicular with the pipe to show that it's in the open position, and so yeah, parallel with the pipe to show it's open, and perpendicular to the pipe to show that valve is closed. We do say correct position. We don't actually say check that they are all open, because there are some exceptions to that, particularly if you have a bypass line on your installation control valve, then that valve is normally closed. So that's why we don't say make sure all the valves are open. We say it isn't quite as simple as that, although the vast majority of valves should be in the open position at all times. Number 4, check the water motor alarm test. So we're going to go through that in a little bit more detail here. So on the left-hand side of the screen, I've given you an example here of an installation control valve. This is a Model E from the company Reliable. So one of the companies that make installation control valves. And on the right-hand side, I've got more of a kind of schematic drawing, which we have kind of been through before. But the point is, how do we test the water motor alarm gong? The water motor alarm gong on the right-hand side is labelled 8. Remember, that's a water-powered bell. On the left-hand side, that bell hasn't sort of been connected, but it'd be connected onto that line there. You can see where I've labelled it 8 on the left-hand side, so there would be some pipe work attached into there, and then the bell fitted. It doesn't come with the alarm valve doesn't come with that kind of pre-fitted. Because it'll have to have a massive box, it might get damaged, and also the exact location of the bell is not known at the point of kind of ordering the alarm valve, so that was normally piped in separately. So the water motor alarm gong is there to alert you of the alarm valve activating. I think, again, as I have discussed on Sprinkler Talk before, it's a very kind of old technology, really, and it's something that is really kind of being phased out. What's more important, really, is number 7, which is the pressure switch. Now, you may also have a flow switch as part of the setup, but more commonly we'd have a pressure switch, and that is giving you your digital alarm. And that pressure switch is labelled as number 7 on our diagrams there. So we're calling it a water motor alarm test. What we're really doing is checking the correct function of the alarm valve itself. We're checking that the clack opens, number 5, and that the water comes through the annular groove, 6, and then sets off the pressure switch, 7, and the water motor alarm gong, 8. So we're calling it a water motor alarm test, but as I say, really it's a test on the function of the alarm valve. So what do you do to test it? Well, you open the test line, which is labelled as number 1 on the left-hand side and on the right-hand side. You can see that the kind of drain line has got 2 valves, 1 and 2. So 2 is the full bore drain. So that is kind of full-sized drain. So you would use number 2 if you wanted to drain the installation. So if you're doing some maintenance work, for example, you want to drain the whole installation, you would save time and you would open 2, and that would drain it quite quickly. When you're doing the water motor alarm test, you should be opening valve 1, because that has been sized smaller to simulate 1 sprinkler head in operation. Although there also may be a orifice plate fitted into the annular groove, etc. But yeah, we should be opening the test line number 1. What that will do is that will lower the pressure in the pipework, in the riser, which is labelled number 3. That pressure will drop, and remember that pressure is actually holding the alarm valve closed, because we have pressure underneath the alarm valve 2, which is shown as number 4. So by opening that valve, we drop the pressure above the alarm valve. That is going to cause a pressure differential, so that the pressure below is then going to be greater than the pressure above, and the alarm valve clack number 5 will open, and so the water will exit the alarm valve through the annular groove 6, and then activate the pressure switch and the water motor alarm gong. And then obviously be testing that the signal from the pressure switch comes through, and the codes ask you to ring the bell for 30 seconds. Once that test has been completed, you would then close the test valve 1, and then it would basically the clack will reseat itself. The water will continue to flow from from 4 towards 3 until things kind of equal out again, and then the clap will close automatically. The water in the annular groove will drain itself. The number 9, well, number 9 is showing you that the drain actually, but yeah, just there is like a drip union, it's called. So that line will clear itself slowly through the drip union, and then it will then go dry again. So that's how you do the weekly water motor alarm test. Alternatively, we have a product here called BellCheck. This is something that the Project Fire have invented and Project Fire manufacture. So this is a bit like our flow switch product, our zone check product, which is coming up later. But this is designed to test the alarm valve. So we have a pump. We have like a little kind of bypass line around the alarm valve. We have a non-return valve and a solenoid valve on that bypass line. So we're not allowing water to flow through that line unless we're doing a test. When we do perform a test, you can see we've got a pump unit there, and what that does is it pulls water from above the alarm valve and it pushes it in below. So again, we're creating that pressure differential. That will lift the clack, and then we're going to circulate water. And as soon as that clack is open, then it's going to set off our water motor alarm gong and our pressure switch in just the same way as the manual test. So why do we do it? Well, it makes the test easier to complete. In a kind of shop unit, for example, it may well be the responsibility of the shop staff to carry out this test. So if we can make it as simple as possible, that's going to benefit them. And also it saves a lot of water. Well over kind of 200, 300 litres of water per test we can save. It does depend on the size of the alarm valve. It depends on the correct operation. It depends how long you ring the bell. It depends how long it takes for the signal to kind of come back through to you to enable you to close it off again. And it depends on, say, whether you remember to use the test valve rather than the drain valve. So the amount of water that you save is going to vary, but it's going to add up to quite a lot because we're doing this test every week. So this is a sustainable product. Test the alarm valve without draining any water off the system. And it's also going to help with corrosion as well. Again, corrosion is a topic that we'll cover later on, but essentially, if we can reduce the amount of fresh water coming into the system, then we can reduce corrosion. So by circulating water rather than discharging it, we're going to help with improving the longevity of the pipe and the components as well. On the left-hand side is a shot of our fire pod. Our fire pods are prefabricated units. This one is showing an alarm valve fire pod with a life safety bypass line with monitored valves. It's all been pre-wired and pre-assembled and tested, and that has a BellCheck with it as standard. And so if you want more information about BellCheck, they can go to our website, www.projectfireproducts.co.uk/products/BellCheck, or you can just follow the links. The question here about approval on the BellCheck. Yes, it is LPCB approved. It is not FM approved. That's not because we kind of had any kind of issue with it. It's just that we've never submitted it for FM approval because the sales that we've had have been UK based, and so we know that LPCB is the one for the UK. It is also VDS approved, so we have the kind of European approval on this as well. But no, it's not FM, but it is LPCB and VDS approved, and RAS approved as well, because we could be using it on a town main system. So again, it is RAS approved to be used in that situation as well. Okay, so that's number 4 on our weekly routine, a water motor alarm test. Number 5, automatic pump starting test. To do that, you need to access the pump initiation board. And that looks a little bit like this. The ones that you see on site may not be quite as brightly coloured as this one. I've kind of made it so that it's nice and easy to see all the different components, etc. So the pump initiation board is a method of basically tricking the fire pump into coming into action and the jockey pump into coming into action. So in a fire situation, we've obviously got water coming out of the sprinkler heads, which is causing a drop in pressure. That drop in pressure is going to open the alarm valve, and that's going to cause a drop in pressure into the pump supply line, and that drop in pressure is going to activate the fire pump to come in to feed our sprinkler system using water from the water storage tank. This initiation board allows us to essentially kind of trick the fire pump into thinking that there's been a sprinkler activation and check that it's coming in at the right pressure and it's coming in so it's actually working correctly. So obviously we could do that by setting off sprinkler heads, we could do that by opening drain lines, but this is a more convenient way of carrying out that test. So let's look at a few of the components we have here. So first of all, this is what we're showing here is a two-way initiation board. So in this particular system here, we have one jockey pump and one fire pump. If it's a life safety system, then we would need a three-way board. So you'd have one jockey pump and two fire pumps. And if it's a particularly large system, or you're using a different code standards, or for various reasons, you may even have a four-way board, which would be one jockey pump and three fire pumps. When you have three fire pumps, we're kind of going off topic over here, but when you have three fire pumps, generally speaking, that they work as a team. So you have two fire pumps that are working together to meet the pressure and flow demand, and the other pump is like a standby. So we need any two of the three to work in order to meet the demand. Anyway, back to the topic. So we have system pressure coming in at the top, and for example, I've said that's 6 bar of pressure. Okay, so that is the pressure on our B gauge. Essentially, that is kind of normal sprinkler pressure. So in a fire, that system pressure is going to drop, and that's going to call the fire pumps into action. We have some pressure switches. You can see they're labelled there. That's the black shape there. So we've got 1, 2, 3, 1 for the jockey pump and 2 for the fire pump. Again, that's kind of a backup thing. We have 2 pressure switches for each fire pump. In case one pressure switch doesn't work or doesn't work reliably or whatever, we have a backup pressure switch. We then have some valves, and we have a kind of drain line at the bottom to carry the test water away. Hopefully you can see this okay. By the way, I've noticed on my phone that the presentation kind of cuts off a little bit. I can't see the bottom of the slide, but hopefully that's not the case for you. And also, even if it is, that you can still just about see everything. So what do? We want to test pressure switch 1. So pressure switch 1 is going to be calling for the fire pump to come in. So what do? Well, we close test valve 1. What that does is it isolates the pressure switch 1 from the system pressure. So it stops the system pressure being able to kind of top up the system, because that's what would normally happen. So we want to stop the system pressure from dropping. We don't want to affect that. So we close that test valve, which is basically isolating pressure switch 1, which means we can mess with pressure switch 1 without affecting anything else. We're then going to open this test drain 1. We would open that very slowly and carefully. It would, generally speaking, it's fitted with a plug with a very small hole in it. So again, we just want like a trickle of water coming out, because we've now got a very small volume of pipe there. So we only want a very small amount of water to come out. in order to drop the pressure. Because that's what we're going to be doing. We're going to be dropping the pressure in this line here. So the pressure gauge at the top there, again, is showing us 6 bar. And as we open that test drain line, that test drain, that pressure is going to drop. It's only going to drop in that area. The yellow circle there is just showing you a non-return valve. That is showing how we can kind of isolate that one area. So the water can come out of that place, and it's not going to be filled up via that T and the system pressure because of the non-return valve. The pressure is going to drop in that localized area, just where that pressure switch is, and that is, of course, at some point, that's going to trip our pressure switch, and it's going to start our fire pump. And all we need to do is to note the pressure at which that fire pump starts, and then compare it to what it's supposed to be. So let's say that fire pump should be coming on at 5 bar, or maybe 4 bar, 4.5 bar, whatever it's designed to do. We would check that that's coming in at the right pressure. If it isn't, then we can replace the pressure switch, or we can adjust the pressure switch and kind of bring it back to where it's supposed to be. And obviously that water is going to be lost to drain. When we finish the test, we're going to open the test valve 1 again, and the pressure into that localized area is going to be restored. Let's go through that again, but this time we're going to be looking at pressure switch 3. The pressure switch 3 is controlling the jockey pump. But the way in which we do it is exactly the same. First of all, we're going to close this test valve here. It should be labelled as 3 rather than 1. We're going to close that valve there. We're going to open the test drain 3. We've got a non-return valve on this side as well, so we're only going to be draining affecting the pressure in that very localized area. The pressure drops in the local area, and then that pressure switch comes in, and it's going to activate the jockey pump in this instance. The jockey pump has actually got a cut in and a cut out pressure. We will be testing both of those in this scenario. So the pump initiation board is a way of testing the fire pump under kind of real conditions, but in a kind of in a manufactured way. We're not going to be affecting anything else. We're not going to be setting off any other alarms. We're not going to be draining lots of water. So we only drain a very small amount of water for each test, because we've isolated a very small volume of pipe. So let's just say it's a convenient way to check that the jockey pumps and the fire pumps are going to come in at the right pressure. This is actually something else that the Project Fire recently started manufacturing. There's nothing particularly innovative about this design. It's a very kind of common design. But what we have done is made it as neat as we can, using high quality components. We printed the boards with nice, easy to follow instructions. The boards can have custom branding on them, and we fitted some Unistrut at the back, again, just to make the installation really easy. So it's a good quality, well-designed board. As I say, in terms of actually what it does and how it does it is very common to initiation boards. So letting you know that they are available as well on Project Fire. Back to the weekly routine. Number 6, additional test on the diesel pump. So that is a kind of an automatic restarting test. So that's another test that needs to be going on the diesel pump if you have one. Number 7, check trace heating. So if you have any trace heating on the system, then that should be connected back to, again, some kind of monitoring box, and you would check for any faults on that box on a weekly basis. The trace heating is stopping the water in the sprinkler pipework from freezing. So that is doing an important job. If that stops working, they want to know about it pretty quick. We don't want the water to freeze, because it will cause a blockage within the pipe, and also water expands when it freezes. So we may well crack the pipe or damage the pipe, and say in extreme case it will actually blow the fittings off and cause a big mess. Monthly routine, we need to be checking batteries. Again, we're mostly talking about batteries as far as the diesel pump is concerned. So the diesel pump will be started off battery, so then it'll be checked on a monthly basis, make sure there's enough charge in them to start the diesel pump. And that is it. So we're just going to do weekly and monthly today. So don't think that that's it for sprinkler testing and maintenance. It is not. There's quite a lot to do on a quarterly basis and an annual basis, and then there's a few other bits to mention as well. So that's going to be covered in part 2 of sprinkler testing and maintenance routine, and that is coming up next week. So I thought for these particular ones that I would do those as 2 sections. So there is a slight change to the program. If you've been following the program on the internet in terms of what presentations are coming up, that's a slight change. But next week I'm going to be doing sprinkler testing and maintenance routine part 2. So I'm going to be picking up where we've left off there on the testing and maintenance routine. Okay, so yeah, thanks much for tuning in. Just a reminder that these presentations are available on YouTube. I think we're pretty much up to date now, so I think we've got at least 20 presentations up on YouTube now. Yeah, do let me know if you've got suggestions for future presentations, and do spread the words. It'd be nice if some of you guys, put something on LinkedIn, for example, to say that you're watching these sprinkler talks and you find them useful. It'd be good to kind of get the numbers up watching these live. But yeah, thanks so much for tuning in. Hope you have a great day, and I'll see you next week at 10 o'clock. Okay, bye-bye.